Hey everybody, welcome back to the next installation of lectures and logic. What we're going to talk about today are truth tables. And a truth table is a table which lists the truth values, that is true or false, of a compound statement. A truth table is a table which lists the truth values of a compound statement. The truth table lists the truth values of the compound statement for every possible combination of truth values of the simple statements which make up the compound statement. That's a lot to swallow at one time. To illustrate, let me give an example. P, Q, those are my simple statements. And I want to construct a truth value for the compound statement if P, then Q, which is also read P implies Q. So we have if P, then Q. So this is the statement, this is the compound statement whose truth values we want. And we're going to give the truth values for every possible combination of truth values of the simple statements P and Q, which make up this compound statement. Now think about it. A simple statement can either be true or it can be false. Those are the only two possibilities. So think about it. If P can either be true or P can be false. Those are the only two possibilities. Either P is true or P is false. Now, given a truth value for P, let's say P is true, there are two possibilities for Q. If P is true, either Q can be true or Q can be false. So we'll write those down here. So we have all of the possible truth values for P and Q when P happens to be true. If P is true, then either Q can be true or Q can be false. Now it's possible that P could be false. And if P is false, there are two possibilities for Q. If P is false, either Q can be true or Q can be false. These are all of the possible combinations of truth values of the statements P and Q. They can both be true. P can be true and Q can be false. Or Q can be true and P can be false. Or they can both be false. Those are all of the possible combinations of truth values of these simple statements, P and Q. And our table is going to give us all of the truth values for the compound statement, if P, then Q, for all of the possible combinations of truth values of P and Q. And I'll tell you what. Here's what the table of truth values looks like. If P is true and Q is true, then the statement if P then Q is true. If P is true and Q is false, then the statement if P then Q is false also. If P is false and Q is true, then if P then Q is true. If P is false and Q is false, the statement if P then Q is true also. So these are the truth values for our compound statement if P then Q. Now I've told you what the truth values are, but I really didn't explain why the truth values turn out to be this way. So let's see. Let's take an example. And while I'm erasing the board, let me just shut off the recorder. Okay, let's consider this example. Let P be the statement, you will wash my car. Let Q be the statement, I will give you $10. So the statement, if you wash my car, then I will give you $10, is of the form if P, then Q. So this compound statement has the same form and structure as the compound statement in our truth table. And let's see how this works. Suppose that P is true and Q is true. In other words, you wash my car and I give you $10. Well, I said if you wash my car, then I will give you $10. And you wash my car, so this is true, and I give you $10. Are you happy? Sure. You washed my car with the expectation that if you did, then I would give you $10. You're happy. Am I happy? Yeah. I wanted somebody to wash my car, and I told them if they did, I'd give them $10. They washed my car, and I was so happy about it, I gave them the $10 like I said I would. So they washed my car, and I told the truth. I did give them $10. Now let's look at the next scenario right here. P is true, Q is false. You wash my car, but this is false. It turns out I don't give you $10. You washed my car with the expectation that if you did, I would give you $10. You washed my car, so this is true. I didn't give you $10, so this is false, and I lied. Are you happy about it? No, I lied to you. If you had known that I wasn't going to give you the $10, you wouldn't have washed my car. So, if P is true and Q is false, that means I've lied. You satisfy this condition, and then I don't make good on my promise. You wash my car, I don't give you the $10, I lied. So, if P is true and Q is false, this statement is false. Now, let's take this statement again and look at the third set of values. I tell you, if you wash my car, then I will give you $10. You don't wash my car. But I'm such a nice guy, I give you $10 anyway. I never said that if you didn't wash my car, I wouldn't give you $10, did I? Did I say that? No, I just said what I would do if you did wash my car. I said if you did wash my car, then I will give you $10. I didn't say anything about what I would do if you didn't wash my car. Well, P is false. You didn't wash my car. But I'm such a nice guy. I say, here, take the $10 anyway. Are you happy? You didn't wash my car, but I gave you $10 anyway. So you're happy. And as far as you're concerned, I didn't lie. Am I happy? Sure. Nobody made me give you the $10. I just did it because I felt like being a nice guy. So if P is false and Q is true, the statement is true. Another way of looking at this is that the statement, if P then Q, makes no guarantees one way or another what will happen if P is false. The statement, if P then Q, is understood to be, if P is true, then Q is true. So this statement only makes guarantees when P is true. Now, the last set of truth values. Both P and Q are false. You don't wash my car, and I don't give you $10. Are you mad at me? No. You weren't expecting to get the $10 because you didn't wash my car. And I'm not unhappy. You didn't wash my car, but I didn't give you the $10 either. So for a conditional statement, an if-then statement, this is the truth table. There are about half a dozen truth tables that we need to know. This is one of them. Know this truth table. And to make it easy, I'll tell you how a lot of people learn their truth tables. They learn the special case. And I guess I will write it up top. This is pretty much how everybody does truth tables. Every truth table has a special case. And for an if-then statement or conditional statement, here's the special case. It's only false when we have true implies false. All other times it's true. When we have true implies true, it's true. When we have false implies true, it's true. When we have false implies false, it's true. The only time that this statement is false is when we have true implies false. So this is the special case that we need to memorize. This will tell us how to fill in the truth values for the rest of the table. So special case for a conditional or if-then statement, it's false when we have true implies false. What I'm about to do next is very trivial. I guess I have to do it, but it's something that's pretty obvious, and that's the negation truth table. Remember last time we talked about this symbol, and this symbol negates the statement that follows. So if P is true, then this thing, which we sometimes refer to as not P, is false. So if P is true, the negation of P or not P is false. But if P is false, then the negation of P or not P is true. And you might remember also last time I said that for some unknown reason, our authors consider this to be a compound statement. If P is a simple statement, then the negation of P, not P, is a compound statement. Why, I don't know. But they wrote the book. That's their business. And they pretty much endeavor to make sure that everything in the book is consistent with their calling this a compound statement. So it's intriguing why they call this a compound statement, but nobody's going to die on the operating table because of whether this is really a compound statement or a simple statement. So we go with the authors. Now, up here it says negation truth table. So let's write down our simple statement. And we just have one simple statement. So why am I writing it twice? Beats the heck out of me. Okay, here's my simple statement. And P can either be true or it can be false. Now here's my compound statement, not P. And remember what this symbol does. It changes the truth value of the statement that follows. So if P is true, then not P is what? False? Okay. Well, suppose that P is false. Then not P is what? True. And this is the truth table. This is the truth table for the negation of a statement. See, it's so simple that I'm kind of ashamed that I actually put this up here, but we should, just to make sure that we do discuss it and we're aware of what happens when we negate a statement. So let's see, we've done the conditional, that is, if P then Q. We've done the negation, we haven't done ands. And we haven't done ors. So I guess we got to do those next. We'll tackle the and statement first. The and statement or the conjunction. P and Q. And the assumption is that they're both true. Let P be the statement, I will make my bed, and Q be the statement, I will clean my room. And we've said both of these things. We've said, I will make my bed and I will clean my room because our mother just said to us, your room's a mess. I want you to make your bed and clean your room. And so, since she's our mother, we promise, I will make my bed and I will clean my room. And an hour later, we tell our mother, I made my bed and I cleaned my room. Is she going to be happy with us? And under what circumstances will she be happy with us? Let's fill in this truth table. And again, for the simple statements P and Q, we want to make sure that we list every possible combination of truth values for P and Q and list each possible combination exactly once. The way we filled out the truth table for the conditional statement, or rather, the way we prepared the statement for the conditional statement, is the way that we prepare a truth table for all statements that involve two simple statements, P and Q. We go to the statement on the left and we put down true, true, and false, and false. And the reason we do this is because for each value, each truth value of P, there are two different possible truth values of Q. If P is true, maybe Q is true, or maybe Q is false. So if P is true, these are all the combinations of truth values for both P and Q. But P might be false. So if P is false, there are two possible truth values for Q. If P is false, maybe Q is true, or maybe Q is false. And this lists all the possible truth values for P and Q, assuming that P is false. These four rows give all of the truth values, all possible combinations of truth values for P and Q exactly once. P and Q can both be true. P and Q can both be false. Or maybe P is true and Q is false. Or maybe P is false and Q is true. The way we filled out this truth table exhausts all possibilities and lists every possible combination of truth values for P and Q exactly once. So if we have two simple statements, P and Q, this is how we prepare the truth table every time. True, true, false, false. And for the true values of P, Q can be true or Q can be false. For the false values of P, either Q can be true or Q can be false. Okay, we've primed the pump, we've prepared our truth value. And remember the situation. Our mother said to us, "Your room's a mess. I want you to make your bed and clean your room." And we said, "I'll make my bed and I'll clean my room." And an hour later, we come out of our room and we say, "I made my bed and I cleaned my room." Now, if both P and Q are true, that means I made my bed and I cleaned my room. We did exactly what Mom told us to do. So is Mom happy? Yep. As far as she's concerned, we told her the truth. And we did. We said we would do both of these things, and we did. Okay. Suppose that I make my bed, but I don't clean my room. So P is true, Q is false. Is Mom going to be happy? If she is, she's the most understanding mother on this planet. My mother would say, "Why didn't you clean your room?" Uh-oh. I told my mother I made my bed and I cleaned my room, and it turned out I didn't clean my room. I lied. This statement's false. My mother is not happy. So what about I didn't make my bed, but I cleaned my room? Well, I did clean my room. That's good. But I lied about making my bed. Mom's going to be very mad about that. I lied. I said I'd make my bed. I said I'd make my bed. I didn't. Okay. Now the good news is, I think I'm a little bit too old for my mother to beat with the belt. The bad news is she's not happy with me. I lied. This statement was false. Oh, what could be worse? Well, it could be the case that I told my mother I made my bed and I cleaned my room, and I didn't do either one of them. P is false, Q is false, which means I lied about making my bed and I lied about cleaning my room. At the very least, I'm not going to get supper tonight. Or if I do, my mother may not serve it on the table. It may come flying across the room at me. Now, this is the truth table for an and statement. something that we call a conjunction. And we need to know this truth table. Well, again, it can be hard to memorize an entire truth table. So we do what most people do who know their truth tables. We hone in on that special case. And this is the special case. Only under one set of circumstances is this table true. The statement P and Q is true exactly when both P and Q are true. So let's see. What did I call this statement? I didn't. I called it a case. Okay. Special case. So people who know their truth tables know them because they know the special cases. An and statement is only true when both of the individual statements are true. That's the special case that we have to know. P and Q are both true, so the statement is true. Everything else is false. See? We just need to know this special case. An and statement is true. It's only true when both statements are true. All other times it's false. Okay, a truth table for another type of logical statement, another compound statement, the or statement. And remember, whoops, I got to change this. There we go. This is read P or Q. And an or statement implies that either P is true or Q is true, or perhaps they're both true. That's the sense of it. And I think this is a good illustrative example. I sold somebody a car and it turns out to be a lemon. So I tell them, I will have your car repaired, or I will give you your money back. Let's write that down. So here's my or, and I will have your car repaired. That's P. I will give you your money back. That's Q. So the statement, I will have your car repaired, or I will give you your money back, it really is an or statement. P or Q. Now, let's just consider for a minute. Let's say that they're both true. I have the car repaired and it's running great, but I feel so bad about the fact that it didn't run well when I first sold it that I give the customer their money back anyway. I have the car repaired and they can keep it, and I gave them their money back. Are they mad at me? Did I lie to them? No, they're probably thrilled with me. They got a car that runs great now, and it's not going to cost them a cent. So if both P and Q are true, then the statement P or Q is true. Now let's look at the next scenario. I bring the car into the shop, and my repairmen tell me, you know what? It's going to cost you a lot more to repair this thing than it is just to give the person their money back. So why don't you just give them their money back? And that's exactly what I do. I want to have the car repaired, but it turns out I can't. So P is false, but I do give them their money back, so Q is true. P is false, I don't have the car repaired, but I do give them their money back. So in the long run, they're no worse off than they were before. No, the car didn't run very well, but I gave them back every cent they paid. They're happy. I didn't lie to them. So if P is false, I don't have their car repaired, but Q is true, I do give them their money back, but they're happy. I haven't lied to them, I've told them the truth. Now, let's look at it this way. P is true, Q is false. I have the car repaired, so the car is running great now, so I don't give them their money back. Now, did I lie to them? Are they unhappy with me? No. The car is running great, just like they wanted it to, and just like they expected it to when they paid me the money. So they're not really expecting me to give them the money back because the car is running great now. So did I lie to them? No. Either I'd get their car repaired or I'll give them the money back. I have the car repaired. They're happy. They got a car that runs. Uh-oh. What happens if P and Q are both false? And I have false or false. I don't have the car repaired, so they want their money back, and I say, I'm not going to give you your money back. Take me to court. Well, they had an expectation, didn't they? That I would do either one or the other. Either I'd have the car repaired, or I'll give them their money back. And I don't do either one. I don't have the car repaired, and I'm such a louse, I don't even give them the money back either. Are they mad at me? Absolutely. I lied to them. So if we have an or statement, when both P and Q are false, then the or statement is false. And this is the special case that we want to remember. An or case is only false when both statements are false. So P or Q is only false when both statements are false. That's the special case that we want to remember. An or statement. So the way to remember a truth table for an or statement, the only time an or statement is false is when both statements are false. Well, it's easy to fill in the rest of the table. It's true all the rest of the time. Okay, so we have our ors completed. We have our ands completed. And we have our if-thens completed. And we know the special case for each of them. What's left? Well, let's see. We did have this thing called a bi-conditional statement, didn't we? Something that we said was if and only if. We'll look at that next. The bi-conditional statement, which we read as if and only if. So here's the logical symbol. The arrow points both ways. And we essentially read it this way. P if and only if Q. End quotation marks. And it's understood this way. P is true if and only if Q is true. So if one of them is true, the other one has to be true also. That's what that means. Now, I'm not really sure that I have a good example for this. So let me just tell you what this thing really is logically, okay? Here's what this thing really is. This is a monster of composite statements. This is really what a bijunction or a biconditional statement is, an if and only if statement. P if and only if Q, what that really means is that if P is true, then Q is true. And if Q is true, then P is true. That's what P if and only if Q means. If P is true, then Q is true. And if Q is true, then P is true. That's what an if and only if statement really means. So, to get a truth table for this thing that's kind of hard to explain, what I'm going to do instead is write a truth table for this thing. Because I think in the long run, this thing will be easier to construct. Okay, here's how we're going to do it. We set up the truth table. Notice that our compound statement is made up of just P's and Q's. So our compound statement is made up of only two simple statements. So we prepare our table by listing every possible combination of truth values for the two statements P and Q. And we always do this the same way. And the reason we do this the same way is so that anybody else who knows truth tables can look at the truth table and understand immediately what we're doing. Anyone else who knows logic and who knows truth tables is going to expect that we're going to have true, true, false, false, true, false, true, false. That's what they expect the truth table to look like. Now, this is the compound statement that we want the truth values for, but it's made up of smaller compound statements. P implies Q, or if P then Q, and Q implies P, or if Q then P. So we'll get the truth values for this compound statement first, if P then Q. So this is a conditional statement. And in order to keep this exercise from becoming an overwhelming task, I'm going to think about conditional statement. What does the truth table for a conditional statement look like? Remember the special case. For a conditional statement, for a P implies Q, or an if P then Q, what's the special case? A conditional statement is only false when we have a true implying a false. It's going to be true the rest of the time. So let's look for that special case where we have a true implying a false, where we have P true implying Q false. Well, here it is right here. P is true, Q is false. So this combination of truth values is going to be false. But since I know that this is the special case for a conditional statement, and that all other truth values are going to be true, I don't have to think about anything when I fill in the rest of the truth values. I know everything else has to be true. I can fill in the rest of this column without thinking. And believe me, the only thing I enjoy more than thinking is not thinking. I know all the rest of these values have to be true. Bingo, I put them in. Now, this whole statement is also made up of the conditional statement Q implies P, or if Q then P. So I'm going to get the truth values for if Q then P. And I'll put those truth values in this column. It's another conditional statement, which means there's a special case. The special case for a conditional statement is what? The special case is that the conditional statement is false when we have a true implying a false. When we have Q true implying P false. Let's see, do we have that? Yep, here's Q true and here's P false. With this combination of truth values for P and Q, the statement is false. That's the special case. Every other combination of truth values of P and Q will yield a true. So I can fill in the rest of this column without having to think. Oh, thank goodness I don't have to think. Okay, so I have the truth values for this thing, and I have the truth values for this thing. I think all I have to do now is just put them together with an and. So this will be my last column. P implies Q, and Q implies P. If P then Q, and if Q then P. Beautiful. Now, in the most general sense, this is an and statement. I have this joined with that statement with an and. What's the special case for an and statement? Think about it. If you don't remember, go back and look in your notes. What's the special situation or condition for an and statement? Pardon the interruption. We have an and statement. This statement and this statement joined together by an and. What's the special case with an and? Did you look it up in your notes? The special case with an and statement is that an and statement is only true when both of the individual statements are true as well. So the only time that this thing is going to be true is when P implies Q is true, right here, and Q implies P is true right here. Oh, that happens here. It happens here also. Son of a gun. There are two cases when both of these things are true. They're both true here, so I put it true here. These two statements are both true here as well, so I put it true here also. All other times it's going to be false, so I don't have to think about what goes here and what goes here. They're going to be false. And so these are my truth values for an if and only if statement. So we recall P if and only if Q is the same as P implies Q and Q implies P. And we have the truth values for this statement right here in this column. So let's tidy up this truth table. We have P, Q, true, true, false, false, true, false, true, false. And here's our statement. P if and only if Q, which is exactly the same thing as this humongous monster that we just figured out. And so let's see. Our truth values were true, false, false, true. Okay, P if and only if Q. Now, how can we do the special case here? P if and only if Q is true exactly when this happens or this happens. They're either both true or they're both false. Now, I think that might be all of the truth tables that we really need to know. There is such a thing as an exclusive or. I'm not sure we need to do that. I'll give it some serious thought. But these 5 tables, the negation truth table, the and truth table, the or truth table, the conditional if-then truth table, and the bi-conditional if and only if true table, those I think are the only ones that we really need to know. And guess what? They're easy to learn because each one has a special case. So if we learn the special case for each truth table, we'll have them memorized in no time, and we will know them 40 years from now. It'll stay with us. So study this very, very carefully. Learn the special cases for each truth table, and we will do some examples. Okay, let's do a few examples. Here, we're given a statement, P and the statement not Q or R. And we remember if we have parentheses, the parentheses tell us, do me first. And for this statement, we're told, determine the truth value of the entire statement if P is false, Q is true, and R is true. Well, I'll tell you how I'm going to do this. P is false, okay. Q is true, so I have a not true, and R is true. And that's exactly the same thing as I'm going to fix this first. Not true, I just might as well write what it is. That's false, right? So I have false and not true is false or true. False or true. What's the special case with an or statement? An or statement, the only time an or statement is false is when both are false. Well, both of them aren't false here. We have a false or a true. So this whole thing is true. So this statement is the same as false and true. What do we know about an and statement? What's the special case? Think about it. Do you remember? An and statement is only true when both statements are true. We have a false and a true. So this is going to be false. So the statement P and not Q or R is false with the given set of truth values. Another example. Here's our statement. The negation of P or not Q. Construct a truth table for the statement. Our statement is made up of, our compound statement is made up of 2 simple statements, P and Q. So we prepare our truth table. We have a P column and a Q column. And we go truth, truth, false, false. And if P is true, Q can either be true or false. If P is false, Q can either be true or false. And now we fill in everything else. I want to negate this statement, so I better know the truth values for this statement before I do the truth values for the negation of this statement. And before I can do the truth values for P or not Q, I guess I need the truth values for not Q. So it looks like the first thing I need to do is get the truth values for not true or the negation of true. So I'll form a special column for the statement not true, rather not Q. And this is easy. The negation sign just changes all of the truth values of true to their opposites. So true becomes false, false becomes true, true becomes false, false becomes true. Bingo, I have the truth values for not true. Now I guess I can do the truth values for P or not Q. So this is an or statement. What's the special case that we learned for an or statement? If you don't remember, look back in your notes for a minute. The special case for an or statement. The only time an or statement is false is when both individual statements are false. So we're looking for the case where P and not Q are both false. Here not Q is false. Here not Q is false and P is false, so this is it. Not Q is false here, but P is true. Not Q is false here and P is false. So both of these individual statements are false here. So for this combination of truth values for P and Q, P or not Q is false. That's the special case. For all other cases, P or not Q is going to be true. We can fill them in without even thinking because we know that special case. Now it looks like the only thing left to do is to negate P or not Q. Negation, P or not Q. And again, with a negation, that's easy. We just take the truth values for P or not Q and change them to their opposites. True becomes false. True becomes false. False becomes true. True becomes false. And bingo, we have the truth table for the statement, the negation of P or not Q. By the way, in our text, our authors have two different ways of making truth tables. The way that we're doing it is in class is we're using the alternate or the alternative method. So if you're looking at your text, we're using the alternate or the alternative method for making a truth table. Another truth table. Construct a truth table for the statement not Q and P implies not Q. Okay. This is a compound statement. It is made up of two simple statements, P and Q. So we construct a truth table for the statements P and Q. And somewhere along the line, we're going to have to construct the truth values for not Q, or the negation of Q. So we might as well do it right now. Not Q. I don't know what that looks like. Maybe a duck swimming in the water. Okay, there we go. The negation sign just changes true to false and false to true. So we have our not Q's done. Now I guess the next thing that we can do is do the truth value for not Q and P. Not Q and P. This is an and statement. What's the special case for an and statement? The only time that an and statement is true is when both of the individual statements are true. So this statement will be true exactly when not Q and P are both true. Not Q's false. No, that's not going to work. Not Q is true. P is true. Here we go. Not Q and P are both true right here. So this is true. Let's see. Not Q is true down here also. Oh, but look. P is false. This is the only time when not Q and P are true. All of the other times, this statement is going to be false. I love it. Just know the special case and we can fill in everything else afterwards. I love it when I don't have to think too much. Okay, we have not Q and P, and we have not Q. So we can do the rest of this. We know what this is. We know what that is. So now we can put them together. Not Q and P implies not Q. This is a conditional statement. What's the special case for a conditional statement? Take a look back in your notes if you don't remember. The special case for a conditional statement. The only time that a conditional statement is false is when we have true implying false. So we look for the situation where this statement is true and that statement is false. Well, this statement is only true here. And when it is true, not Q is true also. So there is never a situation where we have true implying false, which means that this statement is never going to be false. Oh my goodness, we did it again. Now there's one more kind of truth table that we need to look at, and that's a truth table that involves three different simple statements. Okay, we're pulling out all the stops here. What makes this exercise different than the ones that we've done before is that we have three different simple statements that make up this compound statement. We have the simple statement P, the simple statement Q, the simple statement R, which means that we're going to have to prepare our statement for 8 different possible combinations of truth values for P, Q, and R. Now, P can either be true or false. Only 2 possibilities for P. But with each of those possibilities, there are 4 different combinations for Q and R. So, we put 4 trues and then 4 falses. And this will allow us to cover all possible combinations of truth values for P, Q, and R. Now, if P is true, Q can either be true or false. So we do 2 trues for Q, 2 falses for Q. If P is false, Q can either be true or false. So we do 2 trues, 2 falses. Okay. Both P and Q are true. R can either be true or false. P is true, Q is false. P is true, Q are false. R can either be true or false. P is false, R is true. P is false, R is true. R can either be true or false. And both P and Q can be false. And R can either be true or false. So this is how we prepare a truth table for 3 different simple statements. And this covers every single combination of truth values for P, Q, and R exactly once. So our table is prepared. We can get on with doing the truth table. And I guess the first thing we have to do is find the negation of P. And the negation of P just changes trues to falses, and it changes falses to trues. So true, 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 false, 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 becomes true, 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 true. Oh, and that was so nice, I hardly had to think at all. Now, let's see. I guess I want to do what's inside the parentheses first. Q or not P. This is an or statement. What's the special case for an or statement? The only time that an or statement is false is when both of the individual statements are false. So this will be false exactly when Q and not P are both false. Well, not P is false here, but Q is true. Not P is false here, but Q is true. Not P is false here, Q is false, okay. They're both false. Not P is false here, Q is false here. They're both false again. And the rest of the way down this column, not P is true. So we don't have any more possibilities where not P and Q are both false. Which means, without even thinking, we know that all of the other truth values in this column are true. Okay. Well, I guess we continue to do what's in the parentheses, or in this case, the square brackets. We want to do R and this statement. R and Q or not P in parentheses. And this is essentially an and statement. It's R and this thing. Again, what's the special case for an and statement? The only time that an and statement is true is when both of the individual statements are true. So we look for when R is true and when this thing is true. R is true, this thing is true right here. Okay, we got true. R is false, R is true, but this is false. Now they're both false. R is true, and this thing is true right here. So true again. R is false. R is true here, and this statement is true here. So we got another true. And then here R is false. So these are the three cases when R and this statement in the parentheses are true. All the other times it's false. And now I think we can do the whole thing. This thing, if and only if not P. My goodness. Talk about a monster of a truth table, huh? R and Q or not P if and only if not P. And let me put that in. Okay, now that's much better. This is essentially a bi-conditional statement. This thing in the square brackets, if and only if not P. What's the special case for a bi-conditional? A bi-conditional is true when each of the two statements have the same truth value, either when they're both true or when they're both false. So let's look for when this thing is true and when not P is true. Oh, doesn't happen here. But here, well, they're both false. They have the same sign. So we get a true. Here they're false again. They have the same sign. So we have a true. They're false here. So that makes the entire statement true. Here they're both true. One false, one true. No. Here they're both true. Right here, they're both true. And here, not P is true, and this thing is false. Okay. These are the cases when this entire statement is true. Every other time, it's going to be false. Wow. That is a prehistoric monster of a truth table. And I will circle this column just to remind myself that these were the truth values that I wanted. So we successfully completed that. But the really good news is now I can start assigning you homework exercises from the text. And I say that in utmost sincerity, even though I have a big smile on my face. I can assign homework problems because you're ready for them now. And I think you will enjoy doing them.